This is the 2022 BC multiple FRQs with calculator. So the first thing we have between 5 and 10, the rate at which vehicles arrive to a certain toll plaza is given by this. We're to use the number of hours between 5 a.m. is measured in vehicles per hour. Traffic is smoothly at 5 a.m. with no vehicles waiting in line. Right, but do not invalue integral expression that gives the total number of vehicles that arrive between 6 time equals 1 and 10 time equals 5. Okay, remember what this was? A of t was the rate at which vehicles are entering. So if we want to know the number of vehicles, we're going to have to integrate the rate. So we're going to integrate from 1 to 5 of a of t dt. And they asked write but do not evaluate. We could have evaluated that, but it didn't tell us to. Part B, find the average value. So that's going to take the number of cars that pass through and then 1 over the length of the interval. So 5 minus 1 is 4. Here we have to actually find it. So this would be, when you put it in your calculator, this will end up being 375.5369, but it asks us for the number of people. It doesn't make sense to have half of a person or 0.53 of a person, so this is going to be rounded to approximately 376 people have passed through the toll between time equals 1 and time equals 6 or 5. Is the rate in which the vehicles arrive at the toll plaza at 6 a.m. increasing or decreasing? So we're talking about the rate at which the vehicles arrive, and we want to know if that's increasing or decreasing. So we're going to talk about the rate of the rate. So we're going to have to take the derivative of A at the value 1. We do that in our calculator, we get 148.9472. Since a prime of 1 is greater than 0, we know that the amount of vehicles arriving at the toll is increasing. Part D, a line forms whenever the rate is bigger than 400. The number of vehicles in the line between A, T, and 4 is given by N of T, where A is the number when a line first begins to form. To the nearest vehicle number, find the greatest number of vehicles in the line at the toll. So if we want to know the greatest number, we are going to take the derivative and set it equal to 0. So we have to take the derivative of n. Remember, the derivative cancels the integral. So that would be a of x, or a of t, minus 400. And we're going to look for our critical point. That's when the derivative is equal to 0. So we're really looking where a of t is equal to 400. We're going to do that directly in our calculator. You're going to graph a of t, and you're going to graph 400. You're going to see where they intersect. And of course, we have to check our endpoints. So here is our time. Our first endpoint is going to be A, and that's the time when it starts to have a line, so we know that's 0. At B, which is where this is, so T, which is nearly equal to B, is 1.46932 and 3.5977. So this one's going to be your A, then your B. When we plug that in, it's going to be 71.254. And then at the other endpoint, which would be time equals 4, you're going to have 62.3383. So the greatest number of vehicles in line at any given time is approximately 71. Okay, so let's go back and see how this one was scored. So back to FRQ1, you get 1 point for part A. Part B is worth 2 points. You get 1 for using the correct formula, 1 for the answer. Part C is worth 2 points. You got 1 for looking at A prime of 1 and 1 for the answer with explanation. Part D, first point comes in from considering N prime. The second point comes from finding A and B. The third point comes from the answer, and the fourth point from the justification. The next one is your parametric equation. This one is very nicely set up because it's exactly how we want it. We have y1, we want to be x prime, which is dx dt. y2 in the calculator is going to be y prime, which is dy dt. y3 is going to be equal to y2 divided by y1. Remember, that is the slope. y4 is going to be the square root of y1 squared plus y2 squared. And remember, that is the speed, the magnitude of velocity. And if we integrate speed, we get distance traveled, the arc length. So part A, it wants you to find the slope of the tangent line of the particle at time equals 4. So remember, the slope is dy dx, but this is parametric, so it's going to be dy dt over dx dt. So we know dy dt or dy dx at time equals 4. We can go directly into our calculator, and you're going to go on your main screen and do y3 at 4, and that'll give you the value of 0.701018. Make sure you write this, dy dx is equal to dy dt over dx dt. That is sometimes the point. Always write the equations for speed, arc length, all the values that you need. So B, find the speed at the particle when time equals 4. So remember that speed is the magnitude of velocity. So that be x prime squared plus y prime squared. So we know that the speed at time equals 4. In the main part of our calculator, we're going to go to y4 and we're going to plug in 4. And we get the value 5.035300. The second part says find the acceleration vector. So remember that if you have the velocity vector, that is your first derivatives. That's the one that they gave us. If you want the acceleration vector, that is the second derivative of each of these. So in our calculators, we're going to take the acceleration at time equals 4, and you're going to go directly into your calculator again, and you're going to say the derivative of y1 at 4. And then do derivative of y2 at 4. Make sure you write it as a vector. Part C, find the y-coordinate of the particle's position at time equals 6. Well, if they're going to ask us the position at a certain time, we have to know where it is at least one time. We know at time equals 4, our particle is at 1, 5. So if I want the y-coordinate at time 6, that's going to be the y-coordinate at time 4, plus we'll integrate from 4 to 6 of y prime. This is just the fundamental theorem of calculus. If you kind of rearrange things, the integral of 4 to 6 of y prime is y of 6 minus y of 4. So we know y of 4 was given to be 5. And then you're going to integrating y2 from 4 to 6. And when you do this, you get the value 11.5705. So the y coordinate at time equals 6 is 11.505. Make sure that C is not asking anything else. And then part B, find the total distance traveled from 4 to 6. So again, the total distance traveled is the arc length. So distance is equal to the integral from 4 to 6 of the speed. So you're just going to go to your calculator and you're going to integrate y4. And we do that, we get 12.1362. So the distance traveled between t equals 4 and 6 is 12.1362. The second question, we get 1 point for part A. Part B, you get 3 points. You get 1 for the speed, 1 for the first component of acceleration, and 1 for the second component of acceleration. C, you get 3 points, 1 for remembering the integrand, 1 for using the initial condition, and 1 for the actual answer. And part D is worth 2 points, 1 for the correct formula, 1 for the answer.